Unit 4 Review, Problem 4. Every day for an entire week, a cup of coffee was purchased at Starbucks, McDonald's, and Dunkin' Donuts. The temperature, measured in degrees Fahrenheit, was determined immediately after the cup of coffee was served. The following table contains the sample results. Conduct a hypothesis test using alpha equals 0.05 to determine whether the mean serving temperature of a cup of coffee is the same at Starbucks, McDonald's, and Dunkin' Donuts. So this problem asks us to conduct a hypothesis test. So we'll be conducting a hypothesis test procedure to determine whether the mean serving temperature of a cup of coffee, so this test involves the mean, is the same at Starbucks, McDonald's, and Dunkin' Donuts. This would be 3 different populations. So to conduct a hypothesis test procedure for 3 population means, our inferential statistics technique we use is a one-way analysis of variance. Because a one-way analysis of variance is used to determine if the mean for more than 2 populations are all equal. So we'll use this as a guide to all the steps to follow to conduct our one-way analysis of variance. The first step of any hypothesis test procedure is to state the hypotheses. Symbolically, we express those as the H0 for the null and H1 for the alternative. HO, the null, always includes the condition of equality, and H1, the alternative, is always the opposite and not including the equality. In a one-way analysis of variance, the hypotheses HO and H1 are always stated the same. HO is all of the population means are equal. And H1 is always going to be that not all the population means are equal. So now with HO written as all the population means are equal, and H1 is written as not all the population means are equal, we then go to step 2 in the hypothesis test procedure. This is where we identify alpha, the level of significance. It's customary to always use alpha equals 0.05 or 5% in a hypothesis test procedure, unless stated otherwise. This problem does state to use alpha equals 0.05, so we'll use the alpha equals 0.05 level of significance. Now we go to the third step. This is where we use the sample data to calculate the p-value we need in order to reach our decision and make our conclusion. In a one-way analysis of variance, we have more than 2 populations from which we take our more than 2 samples. So we need to enter the data into the calculator 1 sample at a time. To do this, we would enter the sample from the first population into the first list. Here we'll let Starbucks be our first population. So this sample data will be entered into the first list, list 1. Our second sample will be from McDonald's. So we'll enter the McDonald's sample into list 2. And we'll let our third population be Dunkin' Donuts. And so the sample taken from Dunkin' Donuts will be entered into list 3. So now all this data needs to be entered into the 3 lists, list 1, list 2, and list 3. And once that's done, we can then execute the Anova command on these lists to calculate the p-value. The Anova command requires you to execute the Anova command followed by all the lists of data from the samples. In this case, list 1, list 2, and list 3, all separated with commas. To do all of this on a TI-84 calculator, press Stat, Enter to get to the list editor, and then enter in all the sample data into the lists. Then second, mode, quits. And then to calculate the Anova command to get the p-value, we press Stat, arrow over to Tests, arrow up, press Enter to select the Anova command, and then we enter in the list we entered the data. Second one, to bring up our first list of data, comma, second 2 to bring up the second list, comma, second 3 to bring up our third list, close parenthesis, enter, and then the one-way analysis of variance command displays the p-value. Now that we have the p-value, we can go to the next step and reach our decision. In a hypothesis test procedure, the decision is always to reject HO whenever the p-value is less than or equal to alpha, and to not reject HO if it's greater than alpha. After we make our decision to reject or not reject, the last step of the hypothesis test procedure is to state our conclusion. That is, we interpret our reject or not reject HO decision in words of the problem. Also, we need to make sure that we answer the original question in context or in words of the problem. So looking at the TI-84 screen, we can see the p-value. In this case, the p-value was 4.187 e minus 6. The e minus 6 is telling us that the decimal place displayed between the 4 and the 1 needs to be moved 6 places to the left, or the negative direction. All the leading blank decimal places need to be entered with 0 because there are no digits there. The p-value, being a probability, really needs to be round off to 3 places after the decimal. So once we get to the zeros, past the third place after the decimal, we essentially just round this off to 0. So the p-value in this case is essentially 0. When we compare the 0 to the 0.05, we see that it's definitely less than. So we're able to make our decision. Since the p-value of 0.000 is 0.05 or less, the decision is to reject HO. And when we reject HO, it means that HO is not valid. That is, there is a sufficient enough sample evidence to indicate that HO is not valid, therefore should not be concluded. In this case, HO states that all the population means are equal, therefore the sample data here does not support that. And when HO is rejected, H1 is supported. Therefore, H1 is our valid answer. That is, not all the population means are equal. So now we're ready to answer the question. Therefore, the mean serving temperature of a cup of coffee is not all the same at Starbucks, McDonald's, and Dunkin' Donuts.